Okay, so 5-7 is about solving, giving general solutions uh, to trig functions. It should say trig equations. Let's say trig equations. Okay, the first thing we need to start off with is maybe a cosine function here. I don't know why I'm using capital C. That seems pretty unintelligent, but I'll change up. They want something like this, a solution to cosine theta equals zero point 0.8. So I'm going to quickly draw one. Okay, I know I was pretty quick at graphing that, but you understand. I'm just more advanced than some of you guys. But the cosine theta graph is the wave, right? I've drawn it from negative 4 pi to 4 pi. But I've also drawn y equals zero point 0.8. And if you do this on a graphing calculator, make sure your window goes from negative 4 pi to 4 pi if you're trying to graph the... Make your window go from negative 4 pi over to 4 pi for the x's. For the y's, if you want, you can go negative 2 to 2. It's really not that critical. You make sure that you have your calculator in radian mode or you won't get a picture that looks like this. Okay, so once you've got that graphed, you can see that there are several places. In fact, there are 8 places that you see an intersection point between the curve, the cosine curve, and the line y equals 0.8. If you do cosine inverse of 0.8, which is what theta would equal, it's going to tell you 0.644 on your calculator approximately. That is a specific solution. Okay, this is called a specific solution. Not a general solution, but a specific one. That one happens to be right here. I know that that is 0.644 because it is between 0 and pi. And there's only one solution between 0 and pi. The distance, I know this is going to sound funny, but what's the distance between 0 and 0.644? Isn't the distance 0.644? Well, now use that idea, right? This is 2 pi over here. What's the distance between this intersection point here, this solution, and 2 pi? Also 0.644. If I use that logic, then I should be able to find another solution by taking 2 pi minus 0.644 to get an approximate value of 5.639. Both of these are called specific solutions. So if I had asked you a question like, solve cosine theta equals 0.8 for 0 less than or equal to theta less than or equal to 2 pi, then these would have been the two answers right here. The 0.644 and the 5.639. Okay? So we've got those values. If you want to make them general solutions, well, let's go back and look at our picture here. So this one is 5.639. Now notice something. I would like, everybody should probably already know that there are an infinite number of solutions. If you were to continue the cosine wave and the horizontal line, there's an infinite number of solutions continuing in both directions forever and ever and ever. So we got infinite numbers of these things. They really boil down to two separate families with lots and lots and lots and lots of cousins. For instance, the family names are, well, family number 1 is named 0.644. And if I want to find another one of his cousins, I add 2 pi, and that would jump me up to here. Adding 2 pi because 2 pi is the period of the cosine wave. If I add another 2 pi, that would actually jump me up over to this one, which is past 4 pi. Likewise, I could subtract 2 pi once and another time. You know, you could keep doing that forever and ever and ever, and you could find more of the solutions by just subtracting 2 pi. Notice that each time I jump 2 pi, I am skipping over one of the solutions. So that particular solution is not in the family of 0.644. So when we talk about general solutions, we are discussing we're trying to name all of them at the same time. So here's the family member, and then we're going to describe a way to find all of his cousins. 2 pi k. Now you're probably going, okay, what's that? Well, here's the period. K, what's K? Where K is an element of, remember that fancy letter Z for the integers? This notation says is an element of, and of course we know that the capital Z is the letter that's used for integers from the German Zintegers. Now that particular group, now K could be positive, K could be negative, so that takes care of the whole adding and subtracting thing. So I don't have to put plus and minus because K could be a negative number. The other family, which got completely skipped by this family, well, that one looks pretty similar, right? Same thing. Period times K. Those are called the general solutions right there. The general solutions. So we've got specific solutions inside a range of values. And then we've got general solutions where it just names the family as well as how to find all the cousins. And that's the basics of section 5.7. Now there's other examples that we'll get into in class, like example 2 and example 3. But I wanted you to get that down in your notes so you're understanding what it is that we'll be talking about when you get to class. Finding specific solutions and finding general solutions. Now, you'll notice that I wrote the word period in here. Don't think that we're not going to change the period of the function. We know how to do horizontal scale changes, and we're going to do them. We're going to change the period, so this is not always going to be 2 pi. You have to look at the situation and determine what the period is. Talk to you tomorrow. Same bad time. Same bad time.